Okay, good.
Sorry guys. One more time.
Very good morning. My name is Daryl Ian Raja, matrix number 180673.
My name is Maisarah Zakaria, matrix number 180267.
My name is Afiqah Zafirah, matrix number 180246.
My name is Hoe Kai Thong, matric number 179019.
My name is Nesea Janoh, my matric number is 180733.
My name is Raja Aiman. My matrix number is 180878.
My name is Quek Jia, matric number 180607.
My name is Siti, Jazmina, matric number 180880.
Okay, very good morning, everyone.
Morning.
So for today, we will be discussing about issues and challenges in post-mortem interval estimation. So is there anyone who has any idea about this topic that we'll be discussing today?
For me, what I understood from this topic is that the problems that the pathologists or the students will face when you want to determine the time of the death of an animal or human due to post-mortem changes. And post-mortem changes is defined as the degradation of tissues that is associated with the release of proteolytic enzymes from the cells. And this occurs automatically after death, or it is also known as post-mortem autolysis. And autolysis means the self-digestion by the tissue's enzyme after death. And these post-mortem changes will vary among tissues in their autolytic changes due to the content of their enzymes. For example, in liver, pancreas, and kidney, it occurs very quickly, but there are less changes in muscle for that same amount of time. And there are a few things that we can use to determine this, the time of death, and they are rigor mortis, which is the contraction and stiffening of the muscles after death; ergo mortis, the gradual cooling of the body after death; and the last one will be levo mortis, the sucking of blood to the downside of animal due to gravity. So, Jazmina, what do you have to add on with this?
As you had mentioned earlier, there are three things that happen during the postmortem changes, which are the rigor mortis, ergo mortis, and levo mortis. So for the rigor mortis, as you had mentioned earlier, it's the stiffening of muscles, and this is due to the coagulation of muscle proteins. It doesn't. So basically, it spreads across the body based on lactic acid accumulations. It doesn't happen all at once, and it spreads slowly. And this process can occur more rapidly in a cooler environment, or if the individual had performed very hard, vigorous physical activity prior to death. So eventually, after 24 to 48 hours, the muscles will relax, and secondary laxity will take place, which is flaccidity of the skin. So, would anyone else like to?
Can I ask a few questions?
Yes.
Based on our topic, which is issues and challenges in postmortem interval estimation. So, as an example to your postmortem changes, do you have any example of issues and challenges due to that?
Yes. For instance, okay, factors that influence postmortem changes include temperature. Yeah. For instance, enzyme action, which occurs since enzymes work at a particular temperature, as we all have learned in biochemistry. The ambient environment will affect the ambient environment and the body temperature of the carcass. I'm sorry, I'm not very knowledgeable in
Anyone
this
else
matter.
here wants to help out or share?
I
share a bit of my Wi-Fi today. Okay, it's okay, Jazz. So before I start the challenges and issues for post-mortem, first of all, I would like to share about some components that can be used to detect the post-mortem interval. So based on my reading, there are actually a lot of things that could be considered to be the components that can be used, but I choose only two, which is one is the presence of a fly, which is the sarcophagus fly, which actually goes to the dead animal, and these fly actually lay their larvae on the dead animal, and the larvae itself will actually decompose the dead animal. And how do people check for the post-mortem interval by using this fly? They actually check by taking samples of the oldest larvae, and they estimate the age of the larvae, and they could estimate the time of death. And second is the rigor mortis, as Jazmina said, which is the stiffening of the muscles due to the loss of adenosine triphosphate. And in 2 hours after death, actually rigor mortis happens at the starts at the upper body first, then it goes down. So for the challenges and issues for postmortem, I find that there's actually 4 points, which is it could be a challenge for postmortem when there's an effect of the premortem due to the consumption. For example, if a person take alcohol or ingest some toxins, it actually disrupts the cell composition of the normal body, and due to that factor, it makes the decomposition faster. And secondly is the effect of cause of death. Sometimes the cause of death itself could make the post-mortem interval a challenge. And thirdly is the effect of post-mortem treatment on the corpse. For example, if there's when they discover the dead body, and supposedly they could take the larvae of the flies on the body, but they didn't take it, that actually disrupts the post-mortem interval estimation. And the last is the effect of the corpse location, which is the environment factors. For example, the humidity, the heat, or maybe they found the dead body beside the sea, which is high in sodium chloride. It actually affects the condition and the post-mortem interval estimation of the process.
I think I'd like to add into what Afiqah has said. Based on what I've read, there are other issues or challenges that affect the post-mortem interval estimation. As we all know, post-mortem interval is the time that has elapsed since a person or a carcass or an animal has died. So what I've read that issues that affect this post-mortem interval is the first one is the weather conditions of the environment. So basically, different weather conditions or in terms of temperature will affect the corpse or the carcass. In terms of the weight of the carcass, the water content of the carcass, which will lead to different rates of decay of the carcass. So at different rates, this may confuse the pathologist in determining how long this animal has died. Another one that I've read is the movement of the corpse. So basically, for example, let's say this animal was knocked by a car and he died at this spot. But due to the movement of the corpse, let's say by scavenger animals, they drag this corpse, let's say, this carcass, let's say 50 meters from its original position. So this in turn would lead to additional lesions, or let's say artifacts, and also the position or the location in which the animal was found may not correlate with the lesions that are found on the animal. So this may also be an issue for pathologists in determining when this animal died and how this animal died. And the last one they have read is actually the presence of maggots. This presence of maggots actually generate heat on the carcass, and it greatly degrades the corpse. So different amount of maggots actually lead to different rates of decay of the animals, and this actually gives probably contradicting results to different pathologies in determining the time, the time took, or the time the animal died. Does anyone have anything else to add?
I would like to add on to it, since you have mentioned that there are several factors that could affect the postmortem interval estimation, and those examples you have mentioned happens above ground, where there are bacteria and flies and other things that could affect the carcass. However, I have found that if the carcass is found dead underwater or in the sea anywhere, there are no flies. There are not no flies, but there are limited flies and bacteria with presence there. So what I found if the carcass or the corpse were found on the in the sea or in the ocean or some in the ocean, if let's say the carcass is floating, then it takes about 3 weeks for it to decay. So the decaying process is much slower as compared to carcass or corpse found on ground. And it also plays an effect with the factors that affects the postmortem interval estimation includes the temperature of the sea, as well as whether it is floating or sinking, and as well as the condition of the sea, whether it's at the pond or the river or the ocean. This composition in the waters affect the decaying process, because they found out that they made a study where they left the carcass on the sea and in the seas, and it took about 1 week for it to decay. So that interval process may affect the estimation of the time of death of that carcass. So that is another factor, and issues and challenges in postmortem interval estimation.
As in my opinion, from Afiqah and Daryl, what they mentioned before about maggots and flies, these all are arthropods, and yes, it is true that arthropods can cause confusion and not accurate result for postmortem. So from what I read before is that actually these flies and maggots can come from different types of species of arthropods. So, and these different types of arthropods may have different types of life cycle, or maybe different environmental condition for them to colonize in a carcass. So what I mean here is that the colonization by these arthropods affect by the biogeoclimatic zones, which defined as the habitat, vegetation, soil type, and meteorological condition, like what Daryl said just now about the weather around the carcass. So what I can say here is that the effect of colonization of these arthropods on the carcass can cause induce a challenge for the pathologists to determine the death interval of this carcass. Yes. But
Actually, from my reading, the way that we can determine the postmortem interval, except the presence of the arthropods and also insect, like what you mentioned just now, actually the different stage of decay of the carcass itself also can help in determine the interval. So when a carcass dies, when an organism dies, the carcass itself will experience 5 stages of decay. The first one is initial decay, where we can, when we doing postmortem, we can observe the green color changes at the lower abdomen cavity, especially on the subcutaneous surface, or after you expose the fat layer of the tissue. And the next stage will be putrefaction, where the corpse will start to bloat due to the microorganisms activities, and this can lead to unpleasant odor as the bacteria start to ferment the living tissues. And the next stage will be black putrefaction, where the fermentation of the bacteria becomes severe and it can lead to the body discoloration. And then the next stage will be pyrite fermentation, where the internal organs start to liquefy and the body start to dry out. And the last stage will be mummification, where the carcass will start to show a dark lacquery appearance. However, there are some conditions where it can delay or it can fasten this decay process, especially due to temperature and also the pre-mortem condition, like just now what Afiqah mentioned just now. If the carcass is exposed to the sunlight or the photoperiod, so some of the larvae and the insect could have a faster or slower development. So this could also affect our estimation of the postmortem interval. And the next one would be the temperature. So as the temperature increase, the mega development of the fly, like the Sarcosa prophagus fly that Afiqah mentioned just now. So they will have a faster mega development, and therefore this can affect our estimation also. Anybody likes to conclude or answer?
Yeah, I think I will deduce the whole discussion. So I strongly believe that everybody knows what are the challenges that that would cause in post-mortem and its changes. So definitely we want to identify the right cause of the death of a particular organism. So we need to diagnose it properly when it's dead, and it's really difficult because we have these post-mortem changes and these challenges happen all the time. So as we could see, this depends on several factors. Firstly would be such as the environment, for example, the temperature, the pH, whether it's on land or on sea. So interesting thing about sea would be if it takes a really long time for it to die, for it to decay on the sea, I think by now there would be so many millions of dead bodies in the sea which is not dead. But what helps this whole body to, oh my god, what am I talking about? Anyway, we know that the carnivores help to eat all these dead bodies, that's why there's so many dead bodies there. However, moving on, we have the presence of bacteria or saprophytes or detritivores, which helps in decaying this dead body. So this will result in post-mortem changes. From the original lesion, we don't know what's going on. So therefore, the pathologists, especially in the most related field, would be the forensic pathology in determining the original lesion to know the real cause of death. And finally, I think it's very important for the pathologist to know about the whole autolysis process in the cells to identify the stages as what Kai Thong has mentioned, the 5 steps, so that we could estimate. I don't think we could get it in exact number, but just to estimate the stage of decay. Okay, so finally, I think the pathologists really need to acquire such skills and knowledge and integrate them together, and just to identify and to estimate by identifying the cause of death, the time of death, and whatever parameters which is necessary in post-mortem. So that is all from us, I believe. Thank you so much, everyone.
Thank you.